Polypropylene is a synthetic, thermoplastic, nonpolar polymer. Polymers are substances whose molecules contain many identical structural units, long chains of compounds. Polymers can be natural or synthetic. Natural polymers include starch, cellulose, proteins, and nucleic acids. Synthetic polymers include plastics, fibers, and rubber. The synthesis of polypropylene begins with oil and gas raw materials. At oil refineries, propylene is extracted from propane, a colorless gas that will become the basis for the future polymer. Propylene is purified of impurities such as sulfur compounds and moisture, as these can affect the reaction. It is then sent to a reactor, where it is converted into a polymer under the influence of catalysts. This process is called polymerization. The propylene polymerization process takes place under controlled temperature and pressure. Imagine a propylene molecule. It consists of 3 carbon atoms, 2 of which are connected by a double bond. In the reactor, under the action of the cyclinate catalyst, this bond is broken, and the freed carbon atoms begin to attach themselves to neighboring propylene molecules. Ziegler-Natta catalysts ensure the production of polypropylene with a high degree of isotacticity, which makes it mechanically strong and heat-resistant. After polymerization is complete, the polymer is purified and dried. The polypropylene is then cooled and cut into small granules with a diameter of 2 to 5 millimeters. These granules are a versatile raw material. They melt easily, are easy to transport, and can be mixed with additives in subsequent stages. After polymerization, the resulting polypropylene is presented in the form of granules that can be used in 2 different ways: injection molding and extrusion. The main difference between these 2 methods is the melt flow index, MFI. The higher the MFI of a thermoplastic, the lower its viscosity. Extruded polypropylene has a low MFR, usually up to 1 gram per 10 minutes. This is necessary for the material to retain its shape during the drawing and forming of products. Injection molded polypropylene has a high MFR, usually 10 to 50 grams per 10 minutes, which allows it to easily fill molds during injection molding. Let's take a closer look at injection molding and extrusion. Extrusion, conversion of polypropylene into long products, rods. After synthesis, granules with low MFR are sent to extrusion lines. This process involves several stages. 1. Feeding into the extruder. Granules are poured into the hopper and fed into the screw system. 2. Melting. Under the influence of temperature and mechanical mixing, the material turns into a viscous melt. 3. Product forming. Molten polypropylene is pressed through forming nozzles, creating rods, films, pipes, sheets, and 3D filament. Cooling and stabilization. The resulting product passes through a cooling system, acquiring its final shape. Cutting and winding. The material is cut or wound onto reels, preparing it for further use. The extruded rods obtained in this way are intended for welding the same extruded sheets. Molding. Preparing pellets for molding production. Now let's look at pellets intended for molding. Before they reach the molding production stage, they undergo compounding, a process of modifying the polymer by adding various components. Feeding into the mixing extruder. The raw polypropylene is loaded into the equipment where it is melted. 2. Adding modifiers. The following are added to the molten polymer. During the compounding process, various additives are used to improve the properties of polypropylene. Carbon black elastomers, rubbers, graphite chalk, calcium carbonate, talc quartz flour, carbon fillers, plasticizers, stabilizers, antioxidants, prevent oxidation and thermal decomposition. UV stabilizers, protect against destruction under the influence of ultraviolet light. Anti-static agents, processing additives, anti-blocking agents, flame retardants, and others. Dozens of different additives in terms of quantity and up to 50% by weight. Mixing. All components are evenly distributed throughout the polymer mass. Cooling and granulation. The finished material is cooled and reformed into injection molding pellets, but now with an increased PTR, 10 to 50 grams per 10 minutes. These modified pellets are now suitable for injection molding. Injection molding. Forming complex products after compounding, the pellets are sent to the injection molding line. The process includes 1. Feeding into the injection molding machine. The pellets are loaded into the hopper and fed into the heating cylinder. 2. Melting. The material is heated, turning into a fluid melt. 3. Product molding. The molten polymer is injected under pressure into a mold, where it takes the desired shape, for example, a bumper. 4. Cooling and removal. The product is quickly cooled and hardened, after which it is pushed out of the mold. The injection molding method is used to produce car parts, bumpers, panels, body parts, and other products. Thus, molding and extrusion are different processes that intersect in only one place, in the minds of marketers. Thanks to their high-quality composition, bumpers serve for decades in extreme conditions, under the scorching sun, in frost, with sudden temperature changes, and various mechanical influences. They hold paint well and much more. Extruded rods, due to their poor composition, deteriorate in the sun in a matter of months. Such rods are brittle, rough, fragile, and do not hold paint. Trying to degrease and paint such a rod is like trying to degrease and paint a paraffin candle. Pure polypropylene is essentially grease. Paraffins will constantly rise to the surface and cause layers of paint to peel off, no matter how many times you degrease it. Open flame treatment, flaming. The surface is briefly treated with a gas burner flame. The flame oxidizes the plastic surface, creating chemically active groups OH, COOH, and exposing minerals, which improves paint adhesion. Without this treatment, the paint may peel off due to low adhesion to smooth plastic. Flaming makes the surface rough and chemically active, ensuring the durability of the coating. The specifics of production, in particular MFI, make it impossible to produce rods from high-quality casting compounds. Pouring casting granules into an extruder is like trying to make minced meat out of water. Therefore, all rods that you can find on sale are extruded and in no way relate to lithium compounds, bumpers. Extrusion is in no way related to casting compositions. Welding materials. BAMPERUS are the only ones in the world that are manufactured using a unique technology based on high-quality casting compounds specially designed for plastic repair. BAMPERUS welding materials have all the necessary properties, meet the high requirements for bumper compounds, and are additionally